All right, we're studying type 2. Baseball is hit at an angle, and it initially has a full velocity of 40 meters per second. So I'm asked to draw a little diagram. That's what's going on. Here's my 50-degree angle. And what's the objectives? To study the projectile problem by dividing the event, it's the path of a baseball, into two axes. The x-axis, which is horizontal, and the y-axis, which is vertical. And then I can identify three variables in each axis, solve for missing quantities. And here's the most important. That's why I underlined it. I can use the double time concept as a helper idea to solve for information between the two axes. All right, complete the chart, answer the questions. Baseball is hit at 50 degrees with initial speed of 40 meters per second. Draw the diagram. And then you want to label the component velocities. Well, the velocity in the y-axis, look over here, and I've already explained how you should solve that, but the quick idea is in the y-axis, that's going to be the opposite over the hypotenuse, so the component. So that's your full velocity, and that's your component part. So here's my full velocity, 40 meters per second, and then I'm going to put sine, so that's going to describe the opposite length, and that's going to give me that length, and that angle of 50. When I do want to do the x component part, that moves it sideways / horizontally. That's v initial in the x, the full 40, cosine that. Maybe I get those numbers right now. Makes it easier. Put it down. Put your calculator, clear it. 40 sine 50. 30.6 meters per second. It's my dog. I can hear her. 40 cosine 50. I'm going to leave that 25.7 meters per second. Put that in. Hey, doggy. Want to see my doggy? Go away. Go away. Go away. There she is. A little entertainment. Come on. Back to me. After she. Forgot. That's always wicked noisy when I have later. All right, let's put information down. What we know, what we don't know. So the x component never changes. 25.7 meters per second. That never changes. 25.7 meters per second. That means no matter where this ball is going, it has the same length, even at the top part, the max height. It is moving horizontally at the same arrow, same vector arrow length. All right, other things that we know. Well, we know the component going up, that's the y part. That's the y part right here. Right? That is 30.6 meters per second. That means it goes up at that, and it gets a little less, and then until it's like nothing, and then it like starts dropping down, and it gets larger and larger and larger. So like if we looked at it right here, it's a little arrow, and the arrows keep getting longer here as it goes faster and faster as it goes back to the earth to eventually get to negative 30.6 meters per second. And at the max height point, the velocity in the y-axis final will be 0. So put a big goose egg there. And that means when as I'm going up, because remember we're just studying going up, right? I'm going up and down. There's a symmetry here. And that's a y symmetry, right? That this, when it goes back down, its initial velocity in the y-axis will be 0. So this one's 0. We're almost rocking and rolling. We're always looking for three things. Let's fill in our chart. There's no acceleration horizontally. That's standard. The acceleration only happens vertically. 9.8 meters per second squared. Negative influence always. Even if you're going up, the influence is to pull it down. As you're going down, then the negative influences makes it speed up. All right, so now I just got to find times and distances. Let's start here, because remember, this is just a loop, because all these are zeros. These are zeros. There's no acceleration sideways. Let's put some information down. All right, now I got to get my reference table. Let's dt. Let's solve for time. Maybe I use the other one first. Oh, that one's probably easy. Let's do that one. Solve for time. I have these two numbers and I know gravity. Let's solve for time first. So I say V, so on the y-axis, V initial equals, V final equals V initial plus AT. V final equals, I'm going to put numbers in now. That's 0 because that's the max height. Max height right there is 0. The V initial, just the component part, not the full 40, just the component part, because remember it shot up in an angle. That's less. It's going to be less than 40. It's 30.6 plus negative 9.8 times t. Subtract 30.6, subtract 30.6. Negative 30.6 equals negative 9.8 t. Solve for time. Whatever you get here, this is going to be the same. Up and down. Then how are you going to solve for d? D can be found equaling this. Vt plus 1/2 at squared. Can you use the other one? Yeah. Seems more annoying though. So put that in. Don't forget to square it. So I'm going to put V initial 30, whatever that t is, plus 1/2 negative 9.8, whatever that t is. And don't forget to square it. Square it. Then when you put your time in, the time's going to be the same. The maximum height will also be the maximum drop because it's going up and down. So the maximum height, this dy, will be the dy going down. Technically, you're supposed to have a negative down here too. So like that's up and that's down. Then the last bit, you're going to do the x-axis. And the x-axis, this is the only equation that really matters. You're going to have this time is doubled. So double it. Why? Remember, I can use the double time concept as a helper idea to solve for information between the axes. So these two times will be the same, going up and going down. So that going up, that going down, these will be the same. But in order to find the total flight time, it goes up and down. So you got to add that together. Then you're going to solve for your dx. This is the only equation that works. Vt. You got to use the x component. So I'm going to do going to use the x component. So you're going to use the 25. This is the error that always remains the same and never changes. Times the time. That better be double. So whatever you have here for time, that's kind of weird. Make sure that whatever that value you found over here, you're going to divide, right? Then you're going to put that in there, find your dy, sorry. And then for your dx's, that better be a double time. Double it. Voila. Then the horizontal range, that's your dx value, whatever you just found. Put that in. And the max height, that's your dy value. So what are you found here? This would be your dy. Voila.